Okay, so looking at this mountain, starting from the left to the right, the left part was the uphill part. In math, we also call that increasing. So the uphill is the increasing, and then the downhill is the decreasing. Raise your hand if you thought the steepest part was from A to B. Raise your hand if you chose B to C. Raise your hand if you chose C to D. And raise your hand if you chose D to E. All right, good. A lot of you said that D to E here was the steepest part. And then the downhill can have a steepest part too. So it's done here. What was the steepest part for the downhill? Was it 1 or 2? 2 and 1. So I hear some disagreement, 2 and 1. So the steepest part would be the part, like if it was a slide, the part you would go fastest on. Which part would you go fastest on? Yeah, good. So it's fine if we didn't know it before, now we know it. All right, so steepness of the line is the slope. All right, so for number 1 on this one, it says take a minute to write the coordinates of the points. And so I'm going to give you a minute to do that. I'm just going to give you a little reminder. I'm going to do point B. So the x coordinate comes first. Remember, it's x comma y. And so the x coordinate is starting from 0, you go to -6, and then you go up 1. So this is -6, 1. Okay. All right, so you guys take a minute and see if you can do the rest of those. All right, so some of you guys are just really anxious to move forward to the 2, but I do want to make sure we can do the coordinates first. So I'm going to ask a couple of you to share some answers with us. Like for point A, Kai, can you tell us what you got for that one? -10, 0. Excellent. And Joseph, what did you get for C? Good. Nadim, did you get D? Do you want to give me a different one?
Yeah, E is
2, 9, good. All right, Amen, did you get D or F? Yeah, very good. And who has the last one, D? Go ahead, Emra. Excellent. So for some reason, the 0 ones are tricky, and a lot of times people get them out of order, but Amro had that right. It's 0, 5. All right, any questions on those coordinates? We good with those? Okay. So the slope formula that you might remember from Algebra 1 is the second y minus the first y over the second x minus the first x, okay? So point A was -10, 0, and point B was -6, 1. Okay, so it's the second y minus the first y, and the second x minus the first x. All right, so we've got like a little bit of work with negatives in there. I saw a few of you were working ahead on this, and you might already have an answer. I'm going to say if you're not 100% sure of how to work with the negative numbers, you can always use a calculator in this class. The phone calculators are going to be tricky with the minus negative. I would suggest going into Desmos so you can type the whole thing and look at it and make sure you're doing the right thing. You can use Desmos on your phone too. So this is -6 and a 10. we changed it to plus, that was smart. And then, well, so 0 minus 1 is negative 1. But let me see. Negative 6 minus 10. Oh, so since you started with this one, with negative 6 like that, then you want to continue with it and do 1 minus 0. Okay? Yeah. So that's the right answer. Yeah, I would prefer that you change the bottom there to 1 minus 0. Good morning, Dinar. So we're on the second page right now. You didn't miss a whole lot. Sarah, how are you doing with that? Come in, Jochen. Hi. Okay.
Yeah.
So do you want to count them by class?
Yeah, sure.
Are there any sophomores who dress up? Sophomore, right? No? Junior? Are you a sophomore or junior? Sophomore. So one sophomore. If you were a junior who dressed up, can you stand up? 11th grade who dressed up? You guys are 12? You guys are 12, okay. So that was 3, right? Alright, seniors who dressed up? I think so. Will you count her with her South Lake sweatshirt?
Yeah.
Thanks. Will you count me for math?
Yes.
Yeah.
What department?
Math, yep.
Alright, that's all. Thank you guys.
Thank you. All right, so I saw a lot of good work on your papers. Let's see. 1 minus 0, that was the easy one. For this one, some of you remember that minus negative makes plus, positive. And so a negative 6 and a positive 10 is a positive 4. If those numbers are still tricky for you, just make sure you know how to do that on a calculator. So we have a slope of 1/4. Then it says find the same slope using rise over run. So some of you might remember that this is an alternate way to find the slope, and you go from A to B. So the rise is how far did you go up? And that was 1. And then the run is how far did you go over? And you have to count. You're not counting lines, you're counting how many boxes you went over. So you have to go 1, 2, 3, 4 boxes over. And it's the same because it should be, right? 2 different formulas to find the same answer. So 4 is which method do you prefer? Do you prefer the formula, or the rise over run? And 5 is a thinking question. And I'm going to give you some time to think about that. These aren't like crazy different formulas. They're actually doing the same thing. So if you have some insight as to how these formulas are the same, I'd like you to add that there. So the first one's easy. Which one do you prefer? And then how are these formulas the same? So I want you to take a minute and put your thoughts down on that. And you can share with a neighbor if you want. Sorry, I forgot to record. How the formulas are the same. Some of you told me that they get the same answer, and that's true. And I'm also looking for the reason why they get the same answer. I saw something interesting on Kevin's paper. Kevin, can you read your answer nice and loud for us? All right, so Kevin says they both count the rise and the run, and he's right about that. When we subtract the y's, the 1 minus the 0, that's finding us the rise. And when we subtract the x's, the negative 6 minus the negative 10, that's finding us the run. So I thought that answer was pretty insightful. Does anybody else have an answer besides they give you the same answer and they both count the rise over the run? Amber, go ahead. Oh, I thought you were raising your hand. No? Anybody else have an answer they want to share? Okay, so I'm going to put Kevin's answer. They both count the rise and the run. I think some people like the rise over the run because they're more visual, and some people prefer the formula because their thinking is more analytical than visual. That's my feeling. All right, so let's look at the bottom part. Use your favorite method to find the following slopes. Write your answers down and be prepared to share. So I am going to have you share with a partner. And then after you find these 5 slopes, you're going to make a conclusion about slope. And you might make different conclusions, but some sort of general conclusion about slope. You don't have to practice both methods. You can use the method that you like. Okay? So I'm going to give you some time and I'll come around and see if you need any help. All right, who would like to give us an answer for number 1? All right, anybody else get 1/2 for number 1? Did anybody get 2/4? Okay, so 2/4 and 1/2 are both good, right? Remember that you go up 2 and you go over 4, and so you might get 2/4 to start, but you can also simplify that to be 1/2. It's interesting too because you don't have to use the points B and C in order to find the slope. You can use any points that are on the line. So I could go up 1 and over 2, like right here. See how I hit the line again? That's also 1/2. So 2/4 is good. 1/2 is simplified. That's good. Let's look at C to D. You, Lisa, did you get CD? What'd you get? 2/2. Anybody else get 2/2 for number 2? That's a lot of 2's, right? I think some of you did get 2/2. You might have just done another step after that, right? Yeah, so 2/2 looks good. And then Stephanie, did you simplify it any further? 1/1, good. Or you could just say 1, right? So 1/1's fine, 1 is fine, and 2/2 is also equivalent. All right, DE. Brian, what'd you do for DE? 4/, what? 2? Anybody else start with 4/2? I think a few of you did. 4/2 to start, and then Brian, how did you simplify that one? 4/2, which equals 2, good. Some of you said 2/1, also good. And then some of you said, well, that's just 2, and that's also good. These are all equivalent numbers. None of them are wrong. All right, Nadim, are you checking your work? So far, so good? Okay. Sarah, what about EF? -3. So some of you started with -6/2, right? And then Sarah made that -3. Some of you made it -3/1. But remember, that can also be -3. So any of those are good. And who would like to do FG? Go ahead, Shelby. Okay, over 3 and down 3. So I'm going to put the rise on the top. So I'll put the -3 on the top, because that's the down. And then I'll put the 3 on the bottom. That's the over. And what does this simplify to, guys? And what kind of 1? What kind of 1 would it be? A whole 1, yeah. And it's going to be a negative also, because it's a negative over a positive. That's good. -1. So some of you have -1/1, which is fine. Some of you have just -1. Those are all equivalent. All right, Eamon, are you good with those? Okay, I did not have time to look at your conclusions about slope, but I sure do want to hear them. So if you have something written for number 6, raise your hand to help out the class, because some people have it blank still. Let's hear your ideas for number 6. Amber, did you have an idea for number 6? No? All right, so let's think about this. We need to make some conclusions about slope. What about, let's start with the steepness of the line. We said that this was the steepest part here, right, DE? So the steepest part has what kind of slope? Say it again? I heard something. What kind of slope would the steepest lines have? So it's going to be positive if it's going uphill. So we could actually add that, okay? Uphill from left to right is positive. Slope. And then steeper lines, okay? Which has the biggest number, guys? Is it a bigger number from B to C, from C to D, or from D to E? D to E is the biggest number, and it's also, we said, the steepest line. So steeper lines have bigger slopes. Okay? The less steep lines, like from A to B and B to C, those are going to be fractions. And then the steeper lines are going to have larger numbers, like 1 or 2 or 3 or 4. Okay, so some of you have worked ahead, which is super, but if you haven't, that's fine, because this is where we are right now. We're here. So this is a graph of the money that Jasmine earned babysitting. So you can see if she worked 0 hours, there's no 0, but there should be. There's something weird about this graph. I don't know what that, oh, the -2 is on the y-axis. I'm just going to get rid of that -2. Okay, so if she worked 0 hours, she got $0. If she worked 1 hour, she got $12. If she worked 2 hours, she got 24. So it says to find the slope between the point 0, 0 and 112, and then between 112 and 336. And you can do that with the rise over the run, or you can do that with, sorry, I'm looking at this. Oh, you know what's tricky about rise over run is that they're counting by 2, so I'll explain that in just a minute. But you can also do it with your slope formula if you like the formula. If you like the formula, there is nothing tricky. If you like rise over run, let's just do the first one together. So 0, 0 to 112. So I go up and I go over, but remember that you're counting by 2s, so you can't just count the boxes. You got to count by 2s. 2, 4, 6, 8, 10, 12. So that was up 12. Give me 1 second, Emma. Okay. And then over, this time we're counting by 1s, so that was over 1. All right, so for the first one, rise over run is 12 over 1. All right, and you can do that with the formula as well, remember. Okay, so let's define the slope between the points 112 and 336. So if you use the formula, you probably didn't have a problem, but if you did rise over run, you might have had a problem. So we're going from, let me get a new color. We're going from 112 to 336 here. So a lot of you guys counted up 1, 2, 3, 4, 5, 6 like that. But remember on the y-axis, we're counting by 2s. So it would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So the rise is 24 because we had to count by 2s. And you know that because you're looking at the y-axis and the y-axis counts by 2s. On the x-axis, we're just counting by 1. So that's 1, 2. So it's 24 over 2, which is 12. And then without calculating, can you predict the slope between the middle points here and here? So we knew this slope is 12, and we knew this slope is 12. And so the slope here in the middle should also be what? 12. Good. Because it's 12. Because lines have a constant rate of change, which means it stays the same everywhere. This graph is linear because the rate of change, which is the slope, those are two words for the same thing, is always what number? I see a lot of you on your phone. I want you to help us out with this. The graph is linear because the rate of change is always what number? 12, right? All right. Why does the slope equal this number? What does this number mean for Jasmine? Raise your hand if you'd like to help us with that one. Okay, go ahead, Kelly. All right, Kelly says it means she makes $12 an hour. If you have a similar answer, raise your hand. All right, I see some hands. That's excellent, yes. So it's the rise is dollars and the run is hours, so that's dollars per hour. Dollars. Nice. All right, Dion, are you with us? Did you get all those? Yeah. Okay. Lonnie? Hey, Dion, wake up Lonnie for me. Lonnie, I want you to check your work, okay? I'm going to be coming around to check you off today instead of collecting your work because I want you to be able to keep it. All right, so now we're done here. And it says decide if the rate of change is constant, and if it is, write the rate of change. So remember that the first column is the x's and the second is the y's. So we have to look at how much they're changing each time. So how much is the y going up by here in the first table? That was 60, yep. Is this also 60?
Yeah.
Okay.
So the constant is 60.
Well, we have to check the x's too. So each time it went up 60, and then over here are the x's going up by the same amount. They're each going up how much? 1. Is it still 1? Okay, so the rate of change is the change in y over the change in x, and so that would be 60 over 1, which is just 60.
Why do you say that?
So we said yes because the y over the x is the same number each time. So 60 over 1, 60. 60 over 1 is 60. 60 over 1 is 60. It could, by the way, it could have been 120 over 2. And it would still be okay because 120 over 2 is still 60. So 60 over 1 equals 60. Okay, so I'm going to give you a minute to try B and C and D. B, raise your hand if you said yes, it has a constant rate of change. Raise your hand if you said no, it did not. Okay, so I'm seeing some hands for no, so I'm going to just check that. So this was plus 40, plus 50, and plus 30. So those keep changing. I'm going to see, am I dividing by different numbers? No, not really, right? Because it's just 1 over each time. So I have 40 over 1, I have 50 over 1, and I have 30 over 1. Are those the same number? They're not the same, right? So because they're not equal to each other, I'm going to say no. No constant rate of change. All right, how about C? Raise your hand if you said yes for C. And raise your hand if you said no for C. All right, see, some of you said no, so I'm going to check that out. This was up 150. That was up 90. And that one was 120. All right, but let's check the differences here. 3, 1, and 2. So I have 150 over 3, that's 50. I have 90 over 1, that's 90. So I can already see they're not the same, so I agree with you guys, that's a no. All right, how about D? Raise your hand if you said yes for D. Okay, I see a couple hands for yes. Raise your hand if you said no for D. All right, so I think some people are not sure, so let's check. So I'm going to go up, use a new color so I don't lose track of things. So this one is 30, 90, and 60. So those are different numbers. And then this is 1, 3, and 2. So I have 30 over 1, 90 over 3, and 60 over 2. So 30 over 1 gives you what? 30, and 90 over 3 gives you? And 60 over 2 gives you? 30, so that was the tricky one, right? So since they all equal 30, it does have a constant rate of change. Tricky, right? Okay. So the next thing we're going to do is in Desmos, there are going to be two ways to get to it. You can either go to student.desmos.com and enter a code, or you can just click the link on our slides. So I will show you that.